Okay, let's start. Today, I'm going to talk about replication. What the meaning of replication? What the different way the context where the replication help us while the system design. So let us consider the scenario across the our world. Okay, and multiple regions, multiple locations where the customers are accessing my application, right? So the basic purpose of replication is whatever the data generated by the customer, sent by the customer, we have to ensure that we will make available and consistent across the different users, right? And the major purpose, we don't want to lose my data in anyhow. Something happened, maybe my server failure, my database failure. So what happened if I store my customer critical information in my database? This is very information. What happened if my database is crashed or somehow destroyed, somehow corrupted? That means we are lose our data, and this is not intent of the customer when they are using your software. The customer intention is that whatever the data I'm generating and that's are stored permanently and safe. Whenever I want, I can access this data. So as a software design engineer, our responsibility, we are provide the reliability and to the customer. So how it's possible? So the simplest way is the replication. Whatever the customer information, you can make the multiple copy. Copy one, copy two, copy three. Maybe this is the different region, this is the different zone, this is different region. So in this way, what happened in any situation, something happened on the particular regions, might be this database server are crashed. Still, we have an option, right? Hey, this server is destroyed, this location is destroyed, but already have a multiple copy in the different server. So at least we are giving surety to the customer. Don't worry, already have a multiple copy. Maybe copy to some generally basic number of copies we are putting in the three. Maybe you can go four or five. If this is very critical information, we in as a customer don't want to lost in anyhow, maybe we have to go to the multiple copy of the same data in the different location, different regions. The objective of replication is that first and most, our data cannot lost, and second, it will highly available for every customer with a low latency. So let's talk more about that. So as we discuss, replication is one of the fundamental concept in distributed system and the databases, right? So whenever your applications are in the distributed environments or we are into the database, so in those scenario, whatever the data we applications are storing, are preserving, saving, that's our system must ensure that the availability of data, consistency of the data, and durability of the data. This is the three key factors with respect to the customer data or whatever the data customer want to save. So this is the one you can say the concept, that is replication, that help us if we follow the replication concept process, that will make sure your data is highly available and it will be consistent and maintain the durability of the system side. So replication is nothing, just a process of maintaining multiple copy of your data. Simple. Replication is nothing. whatever the data we have, we are going to the put multiple copy 1, copy 2, copy 3, copy 4, whatever they want, majorly in the different location. This is the concept. So one copy may be region one, another copy may be different region, another copy may be different region. So if one regions are somehow going to destroy something, so replication also help us to meet the fault tolerant kind of scenario. Any server crash, something fault happen, still we are able to recover from the our copies of the data. Okay. So generally, these data, multiple copy of the same data, we are putting in a different location, in maybe the database server, maybe a node, and whatever the data center we are going to the server. The replication is very simple and fundamental concept in the distributed systems, where the your data are distributed across the multiple node, multiple server, multiple location, different region, different location. So in this way, whatever the system we are designing, that will get the your data available to the nearest. You can see the customer, it is the high availability and ensure that consistency and durability of your data. So let's talk some basic concept in the replications which we should aware. So replication meaning simple, making multiple copy of the data and put in different location. Location means different server, different database, different file system. Okay, so one of the basic concept is the master slave replication. Okay, so here this is the simplest way. Whatever the data we have, one our database server become a master server, and maybe that master server, a primary node that accept the write operation, and multiple secondary nodes that keep the replica. Maybe here slave 1, slave 2, slave 3. So one is the primary node that responsible to getting the all the write operations, and later the same contents are I'm going to replicate in the three secondary node or the slave node. This is the master, one master node and multiple slave node, and where data we are putting. And this is the generally many the places where the master slave application is very helpful. Okay, and but due to the nature of you can say your system, your requirement might be sometime you can go to the different concept like a peer-to-peer application. That means, hey, we have a server 1, server 2, or node 1, node 2. So we are going to the put three copy of every places, right? This is the objective. So here say all nodes are equal and each nodes accept write and replica to data to other center. Here in the previous, only one is the master node and that replicate to all other secondary node. Here say each and every nodes play equal role. Anyone can receive the write request, and this responsibility we have to replicate the same content in the other database, right? Might be this receive the request, this server receive the request, they can replicate data here, they can replicate data here. So this is the peer-to-peer application. That means ki all the nodes, all the server are equally same peer, right now, and they have a read and write operation do and repeat. So these are the basic kind of a concept, master to slave application, and second one is the peer-to-peer application. And the this is a major factor. Whatever the you are going to use the master slave or peer-to-peer replication factor. What do you mean a replication factor? The number of copies that data maintain in the system. So generally, nowadays these database replications, all the cloud provider services are offer nowadays, and we as a system admin, yeah, system configurations, we have to decide, hey, this is my important data and I'm going to keep this data of 3 copy, 4 copy, 5 copy. So here the number of copies of the data maintained in the system is known as a replication factor. Whenever you're going to configure, hey, AWS or Google's or Azure asks what the replication factor would be. Here, replication factor means the number of copy you are going to plan, and the objectives of this uh, replications is the maintain the consistency. So here, for the data, whenever you are going to make, this is the one data, okay, and we are decided, hey, I am going to make a three more copy, okay. So whatever the right happen, you are written, you are going to copy here, you are going to copy here, you are going to copy here. They are different region, different location, okay. So the consistency means ki whatever the data here written, the same data would be available here, same data would be available here, same data would be available. Some scenario not happen, hey, some data are available here, but due to some network failure, might be here available data, here available data, but here those data is not available. If customer try to get access read from here, say, hey, data not found. So this say our applications data in consistent non-consistent manner. That means some places, some customers are able to access data, some customers are not able to access data. So this is the sometimes of a bigger problems in the replication. So we have to make sure what consistency model I want. The consistency have a multiple model, you can see. Maybe you can very strong consistency, maybe eventual consistency, maybe casual consistency. They are different layer. Strong means in anyhow each and every server always be the consistent, maybe little bit slow, or maybe something problem happen, roll back everything, no problem. So this, so those name is strong consistency. Sometimes you want eventual consistency. That means ki might be here data available and couple of second at some delay, the data will go to the sync here. So the eventual consistency. Eventual consistency ensure that, hey, data will be going to available each and every server, but might be take some delay while the processing asynchronous processing. Sometimes a casual consistency, maybe consistency available, if not available, still our application is working. I know later part we are going to replicate the data. So these are some basic concept. Whenever we are going to talk replications, please ensure that replication factor and what kind of a master slave are peer to peer, and you have to ensure or talk about your configuration or admins or the cloud provider. Hey, this level of consistency I want to maintain across the multiple node. Strong consistency, eventual consistency, or casuals. These are the basic architectures which we discussed. Like one is the single master replications. Here, the deployment, the way, hey, we have a only single master server and multiple copy of your slave node. So the master slave, the master multiple slave one, slave two, slave three. So here the only one master node and multiple slave node. That means here the this way. And the second one, multi-master replicas. You can say like a peer-to-peer. So here all the nodes, whatever the node we have, whatever the node, they all play like a master. Hey, here also we can play a write operation. Here also can play a write operation. Here also can play write operation. If this write operation, they are going to replicate here. This receive write operation, they are going to replicate here. This receive, they are going to replicate here. So in this way, your these are two kind of architecture: master slave or peer to peer. You can say multi master, where all the nodes play equally. So multi master node, each are accepting write and replica data to others. So these are the two kinds of major architecture: master slave and peer to peer. Or nowadays you can say terminology like single master or multi master replication. The different terminology, you can say single master application or multi-master, or you can say master slave or peer-to-peer. These are different terminology are used, but we are should be aware. And whenever we are distributing replication, the data are split in the multiple node. Each node replicate the portion of data. Sometimes you want to not make a same copy of data in the grid. Instead of just data replication, hey, data are put in the partition data, the different portions, right? So if you talk some how data are replicated in the multiple region, okay. So let us the one region, this is the one node, this is one region another node, this is one region another node, okay. So how data are replicated, how data are synced from here to here or here to here. So this syncing means ki making the copy. Let's see one application server make one data write operation. One data A is written here. So this A are going to replicate here. This A going to replicate here. But what are the way? Okay, there are multiple way to perform this replication. Maybe one is the synchronous replication, asynchronous replication, semi-synchronous replication, periodic replication, or event-driven replication. The different, you can say, approaches you have where you can ensure that, hey, uh, in this way I can approach. Basically, this data that's written here, and after some time I am going to replicate here, maybe asynchronous. Synchronous, the same time data written here, the same time would be written here, same time written here. Means same synchronous manner everywhere. So periodic means ki, hey, say hey, I say hey after 5 minutes this data is going to replicate. Maybe some event driven, some particular user say hey replicate or particular trigger base or particular timing base. So the different approaches available where you think how we replicate this data from master node or to slave node or master node to other master nodes. So let's talk brief about all these so that these are the techniques we should aware why, because we have to choose which kind of a application we are going to need. These are the depend upon your nature of business. You have to select synchronous, asynchronous. Each replication approaches have some kind of a advantage, some disadvantage, some plus point, some negative point. So we as a system design engineer, we should aware which replication methodology we are going to use. In the case of synchronous replications, this is the types of a replication, one of the type of replication where data are written to the multiple node or the location simultaneously, right here. Means ensuring that all the nodes have the same data at the same time. So here in this approach, say whatever the your nodes where data you are going to store. If application write data here, okay, write data here. So at the same time, data written here as well. So all the nodes have the same data at the same time. It is a very strong consistency at every times across the location. Any customers are trying to access data, they always get the same copy from the different location as well. So you can say synchronous replication. Write operation is not considered completed until all the nodes confirm that they have successfully completed data. So here say this hey application they write data. This is the time writing data A. So this transaction is not going to be completed until his slave node this and this both say hey I completed, and then finally say hey I completed. At the same time, every database is going to perform the commit. There are lots of algorithm available which ensure that how we meet this synchronous replication. So the number of steps we can perform here, how to replicate. So first, our request, write request is sent to the primary node or master node. Okay. Second, our primary node write data to its local store. So first, our primary node, whatever the master node, are going to write and its local data first. Okay. And then primary node send a write request to the all secondary nodes. Okay, so this is my primary node, and secondary node, this secondary node, this is my secondary node, this is my secondary node, right? So primary node write data local, and then they say, hey, you write, everyone. And each secondary node writes data in its local and acknowledgement to the primary. So let's keep this retain the local and tell, hey, I done. Okay, let's be written and let's say, hey, I done. So each and every slave are going to acknowledge to the primary, hey, I done, I done, I done. And primary node wait for the acknowledgement for the all the secondary nodes. Here, our primary nodes are waiting. Hey, this is my four child node, four slave. So I have to at least wait for acknowledgement success. And once all the secondary nodes give the acknowledgement, then primary node consider, hey, write operation is complete. And then say, hey, it is complete, everyone can commit. So until then permanent storage. So these are the very, very, you can say, carefully. It will, here again, this is the problem. Here we are ensuring that high level of data consistency across all the distributed node, but we have a somehow delay the performance degrade of the, because here our one node master nodes are waiting to all the secondary node is completed and get the success done, then he's going to say, hey, transaction is complete. So those fraction of times our performance of the system would be delayed, might be during that times those data are not available for other customers. So each have a, some kind of a pros and cons, but here many places our high performance is maybe compromised, but the data durability or consistency is not compromised. The nature of the business, you can think, hey, synchronous replications are help. These are the some kind of a scenario where these are the some advantage. Hey, very strong consistency. That means if all the node at the same time get the same data or none. If let's see, this is the master node and they have a multiple is the slaves, multiple replication pattern. If they have a received data A and here they return, but here they fail. They say, hey, I failed. So all data are rolled back. Hey, dude, yeah, if data exists, then exists for the all my slave node, else don't. If every slave node say, hey, data committed, then master node say, hey, every all secondary node, let's commit the data. So they are very strong consistency and data integrity, and these are the real-time data available, you can see, availability. And again, I discussed these are some problem performance overhead because our primary nodes are waiting to get confirmation from all a secondary node. So there is some latency of my application going to increase, and maybe node due to the node failure, network failure, multiple regions. So these are the some kind of a drawback. Your performance overhead, latency issue can be. So we have to be conscious, be aware. If we are going to plan synchronous replication, we get the strong consistency, data integrity, real-time data availability. But at the same time, we can have a performance overload, low latency problems. Our latency can be going to increase, and some node failure can be. And these are the scenario use cases where basically all the financial transactions going on where the synchronous replication required, because in the financial domains consistency is always required, very strong. So and any real time analytics application or gaming applications where the data is very important, those scenario you can say synchronous replication help us. And for that already these kind of steps, already we have open source and commercial platforms technology available to help us. You can use the Google or AWS or Microsoft Azure. They are, everyone provides such a synchronous replication. Just we have to select, hey, AWS, I need here our replication factor across the region with the number of copy and with the synchronous replications. Just tell this configuration and AWS provide all these synchronous replication facility for your application. And similarly, sometime we go to the asynchronous replication. So asynchronous replication is the also kind of a types of replication where the data is written to the primary node and then replicated one or more secondary node at a later times. So here, asynchronous replication say write operation is considered completed as soon as the primary node is done and write the data without waiting to the secondary node to confirm the read. So here our primary node receive data. Hey, right. This is the multiple secondary node, secondary node, secondary node, secondary node. So if they are written the data here A and they say, hey, I completed and just tell hey replicate, everyone going to replicate. It will maybe some delay, but they are quickly, if written done, they are quickly response hey. So that means the replication between master primary node to the secondary node, that not the same time when the primary is just receive the request, write the data and tell hey all the my secondary node, let's replicate this data, and each one they are going to replicate, but the master primary node say hey I completed, let's inform the application hey it is done. So in this asynchronous, our primary node is not waiting the acknowledgement for the secondary node's replication. So this is the you can say major demarcation between the synchronous and asynchronous. In synchronous replication, our primary node is wait until all the secondary node is not confirmed the acknowledgement hey, they have replicated data. But in the case of asynchronous, master node retain data in his data store and inform hey all the secondary node, let's go replicate them, but master node consider hey my data is completed, retain is completed. So let's just steps how these same idea. First, write application request to the our primary node. That's great. Our primary node. This is the primary node, and this is my secondary node. 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 Okay, this is my secondary. Any write request received here, they first write. So the primary node write data to its storage, they write, and primary node send an acknowledgement the client that indicating that data write operation is completed. Just they first write data and at the same time the acknowledgement, hey, data is completed. And primary node send a write request to one or more secondary node, but does not wait for their acknowledgement. So here they say, hey, let's write the data. Let's write the data. Let's write the data. Let's write the data. And the secondary node write data to their local store and may not immediately. Maybe after some time they will write an update. So there is a no kind of same times this activity happen later part, some delay, some interval, some event, something happen. But they are going to ensure that they are going to replicate not just now, but maybe after some time. So this is the steps generally asynchronous uh, methodology used to implement. Again, lots of places where the each synchronous or asynchronous array. Similarly, here the advantage is that we get higher throughput because our the application receive the right request and quickly respond. Hey, data is written done. So our throughput is become going to higher. Here, latency become very low because our mass primary node are not waiting to get the confirmation from all the application. This will improve our scalability and reduce the network traffic because our request is not waiting. They are not block the networks because they are just receive the request and quickly respond. Our network is free, so our network latency reduce, our low latency reduce, network traffic reduce, scalability improved, and our application throughput also going to become high. So even this is the disadvantage because all the secondary node, this is the master node, all is secondary node, all is secondary node, all is secondary nodes get replicated data. That means eventual consistency. That means it's not the very strong, but here at the same time, here data written, and after that the client say, hey, confirm data is written. And some the same after the client get confirmation, someone going to data read from here might be case the data is not available because eventual consistency means they are going to ensure the data is going to replicate all the secondary node, but it will couple of microsecond delay will happen. So sometime due to that, hey, some data available here, some data is not available here due to the data inconsistency problem as well as. So conflict, so here required the conflict resolution and might be some data loss as well because our primary node is not getting the confirmation from the secondary node. Might be the secondary nodes are not properly write the data. Okay, so these are the some plus point and negative point. Good options still lots of vendor available which offer such a kind of a replication. Maybe our Cassandra available, MongoDB available, MySQL, Apache, Amazon's, Microsoft, Google, everyone, every cloud provider and non-cloud provider, lots of open source software available. That's allow us, you can configure asynchronous replication with the database. Right here, lots of use cases where the generally asynchronous replication are used all the social media application, platform application, caching, big data analytics, IoT or sensor device, CDN content delivery networks. Where all these places you can say uh, asynchronous replication also help us, right? And similarly, I talked about the like different kind of replication methodology like periodic replication. The periodic replication say, hey, they are going to copy the data from the primary node to one or more secondary node at the regular interval, maybe every hour, every day, 5 minutes, 10 minutes. We have to define the period. I'm not you can say primary node is not going to replicate the same time. Instead, other third party, other threads, other application after maybe every 10 minutes, yeah, every half an hour, our data going to replicate. So this is sometimes known as a batch replications or a scheduled replication. You can say periodic replication or sometimes a batch replication or the scheduled replication. Here we are just configure, hey, every 5 minute data is going to replicate across the all my secondary node. Or you can say every week or every 10 days. Whatever the time period, you miss here, we have to specify the time interval on which interval the data replication going to happen from master from primary node to all the secondary nodes. And simple data is written to the primary node, and the primary node is configured to replicate data to one or more secondary node at the regular interval. And at the scheduled time, what are the time schedule? Primary node copy data to the secondary node. Or here you can say primary node, or maybe some separate worker threads are responsible to read data and replicate to other. And secondary node receive data from and update their data with their multiple copies. And again, these are the some uh, advantage because here again our applications, our primary node are not waiting any kind of replication work. Replication works are going to scheduled happen at a particular interval. So our we have to reduce our again our network traffic, improve the performance, and simplify the management here. Again, the same problem here, our disadvantage, data maybe inconsistency, maybe increase the latency, maybe data loss happen. These are the kind of disadvantage, whatever the asynchronous replication similarly. But here the each case scenario, generally whenever we have a backup and recovery system, a data archiving system, a data analytics system, lots of data are going to the large data warehouse, data centers. So generally those scenario, we are making replications on the day basis. the hour basis, right? Not the same. Generally, daily backup or weekly backup, whatever you want, you can just define the interval schedule, and in this way, you can going to provide the periodic replication, not time interval replication. You can say. And sometimes we are listening about the event-driven replication as well. This is the kind of types of data replication where the particular trigger by a specific event and change the state of data rather than the schedule interval. So even they are going to the sync data from there. Hey, this is the primary node, secondary node, secondary node, secondary node. So primary node, secondary node, secondary node, secondary node. Primary node receive data, they written here and just inform, hey, that is done. But this replication to all the secondary node is not work at the same times, yeah, after some delay times or some interval time. Instead, application is wait. Some trigger happen. Hey, some admin say, hey, let's sync. Press the trigger button, or admin say define configuration. If my volume size is become greater than 10, or my the number of retained data is the size 5 KB, so the let's start the one trigger and they are going to the start the replication. So here you can say generally this approach for the real-time replication data and sharing all the nodes on the system uh, at the most up-to-date time. So here say, hey, say whatever the event come, any state change here, at the same time they are going to replicate here. So something they are a mixed kind of a synchronous and asynchronous kind of a. So we are defined. Hey, in the primary data center, I say, hey, any application state change happen the same time, let's go replicate all the data center. So this look like a kind of event driven, not the schedule based, not the interval based, not the same time, not the asynchronous, but the replication going to start on a particular event. Event can be, you can say, hey, in the master, any row change or any update change or any new row insert happen, then go, or any delete happen, particular trigger, particular action, and then you can say, hey, replication going to happen. So here say the particular an event is triggered right now, such as a write operation or change the data. If you can say in the primary node, any insert operation happen, or any delete operation happen, or any update operation happen, at that time let's go and replicate. Okay, so event is detected by our whatever the replication system, and replication system send notification to the secondary, and now they send notification to the secondary server, and secondary server receive the notification and update their copy to data. So these are the event driven replication works, and again they have a, some again some generally all the real time application improve the data consistency and reduce the latency as well as and complexity here. Higher resource configuration, maybe potential data conflict type problem, and generally the real time analytics or financial transaction or IoT sensor device generally nowadays follow the event driven replication. Okay, any event happen in a primary node, any write happen, we are trigger, hey, write operation, let's sync the data. Any update operation, let's sync the data. Any delete operation, let's sync the data. So for different trigger point, you can start syncing data. So in this way, you can say kind of a real times replication happen here, near real time, you can say. And for these event-driven replication, you can use a Kafka, RabbitMQ, Apache Flink, Apache Storm, and even Google, AWS, and Amazon have a event-driven replication facility available where we can use. So these all are the kind of replications we should aware, like synchronous replication. Data is written to the multiple nodes simultaneously, ensure the data consists strong consistency. Asynchronous, that's the data is written to the primary node and then replicated to the other node, potentially leading to some data inconsistency issue, and some semi. Sometime you can make a combine. maybe combine of synchronous and asynchronous replication as well as, but that will define the different factor. And as we discussed the periodical, we have defined the particular regular interval times. Hey, in this time, the particular my data is going to the sync, are event driven. We have to define some event. Hey, this is the my primary primary node. Any state change, maybe in a data, any data return happen, any data read happen, or any data update happen, delete happen, any state change at that state, uh, system is going to give the notification to the, hey, all the notifications, secondary server, let's go sync your data. So nowadays you can say event driven replication is many places are used. So all this scenario, the concept is that whenever you are designing system, and at the designing times you want your system should be highly available. So replication ensure that your data is available even the your event or any node failure, because we have multiple copy of available, right? So we have a, you can say, so any system, generally the requirement is that your system is highly available. Available means they are response. For responding system need a data. So high availability can be achieved with a replication factor as well as. So even any disaster recovery, that means in any unwanted happen on a particular region, locations, some earthquake happen, something data center destroy. So in this way, replications also help us the data recovery, because we have already the multiple copy available of those same data in a different region. So we have recover, backup, and recover and restore our system again. And this help us to ensure the scalability, right? Because our systems are horizontally scaled because you are putting multiple nodes and data putting the reference. So scalability is going to by default increase, because the replication is the concept where you are putting data in a multiple uh, data center, and each data are replicated scale depend upon the users. Okay, and this will also increase your application performance, right? Because your why increase the application performance, because across the location, different geographical location, we have a data center where data available. So whatever the request come from the A region, our data available in the nearest location, we can serve data. And similarly, B customer get data from the his nearest location. So in this way, our read operation is going to improved, because each and every customer or application can read data from his nearest data center, because data is available everywhere across the geographical location. And replication also give us kind of benefits by default if we are implemented properly. They improve the availability, because the data is available for everyone, increase the data durability, protect data as well as if something loss happen, and improve the performance, improve the scalability, and major thing, they help us to meet the fault tolerance requirement. Because replication ensure that anything happen, any failure happen, any disaster happen, your data is still available and we can back up and restore. And for the overall the for the applications, lots of tools, technology, database, file system available. What kind of information you are storing? You are storing data information database or file system, object, images, photograph, for different file storage, block storage. For depend upon the nature of data, you are going to replicate lots of images, video. So these are the different kind of data store, object store, data store. So for those scenario, you have to select a proper cloud provider, sir, the cloud provider, so that they can offer the services. So these replication factors are, you can say, Available technology for our engineering may be open source and as well as the cloud provided. Both technology available. You can go with the maybe Apache Cassandra or Amazon DynamoDB or Google Cloud Spanner. Lots of AWS also have similarly lots of replication software, maybe MySQL replication, Postgres replications you can use, or whatever the cloud-based replication like AWS data migration or big Google Cloud Fusion or a Azure Data Factory, and lots of other software technology available, Hazelcast, Apache, Ignite, multiple technology available. Just you can choose for your scenario. And many nowadays the applications, whatever the applications you can say that are accessed by across the geographical location. So the application is one of the key factors. And nowadays, whatever the e-commerce platforms that are use the replication factor. Okay, and similarly, or social media platforms use the replications. Or similarly, financial institutions use the replication because they are provide replication provide the high availability and durability for the e-commerce platform, social media platform, financial institution where the your data availability and durability is very important, right? Even the you can healthcare organization also required kind of patient data, medical record, everything's billing information, everything. So those scenario also replication is the very information. IoT devices where the replication is required for high availability and all the sensor data sending as early as possible. And similarly all the gaming platform also required the replication, right? So lots of use case and scenario where maybe all the cloud storage maybe replicate the your data in the different region location so that your data is available and ensure that customer durability means the data are always available. Maybe data can be your database or can be file, can be images, can be video, can be any kind of data stored. What nowadays the cloud provider not just support kind of a database replication, actual row column or column filing, even any kind of file, maybe some files, maybe images file, maybe videos file, maybe audio file, maybe any kind of object is stored. Each and everything you want to ensure the data is available, highly available, and maintain durability means they are not going to lose somewhere. And even if we are going to use the CDN, CDN also require the data replication, what are the original data that's are available across the world, across the geographical location, the same replica available to the nearest to the customer so that customer can catch the content and all the images, all the video and play make the higher real time response to the customer. So all this scenario you can say replication play a very important role. So the objective of this replication concept is that we are ensure that our data is available and data is durable so that the data cannot be lost in anyhow. So if we while designing system we have to consider the replication as well as maybe replication can by default we are implementing replication. These are the features by default our system and like your highly available system fault tolerance application system improve the performance. Right now these are the key parameters. Your system is highly available, your system become a low latency, your system become a very performant, right, due to the multiple factors, right? So let's revisit this replication concept, and this is very fundamental about the system designs. So whenever system designs, please keep in mind we have to propose replications as well as so that your system is highly available, your system is fault tolerant, your system have a low latency, and your system become a high performance, and you can go with a real times response as quick as possible. Hope this information is helpful for you. Thank you.